This is going to be the first in a series of 3 videos on integration by substitution. These ones are going to look at the simplest sort of substitution. That's when we're making a linear substitution for u in terms of x. But having said that, I'm going to go for the hardest sort of example we can come across in those situations. So I've gone for one with limits and one where there's going to be a lot of algebra to work out and a lot of integration to do even after we've done the substitution. So the integral we're going to look at is the integral between -1 and 0 of 6x squared over 2x plus 3 with respect to x. Now, there's not really a lot of substitutions. You'll have other ways you can attack this. This one, there's not really an easier way or an equivalently easy way of attacking this one. So first challenge with any substitution is to decide what substitution we want to make, and we want to look at what's complicating this. Now, in this case, the fact we've got 2x plus 3 in the denominator is probably the most complicated part of this integral. If we had 6x squared times something, we could do it by parts twice. This over 2x plus 3 is a bit of a pain, and this means that if we tried going by parts, things would get pretty messy pretty quickly, even though it might be doable in the end. So, given that that denominator is difficult bit, then we should go for a substitution of u equals 2x plus 3. Once we've chosen our substitution, there's 3 steps that we want to make on any substitution. Well, on any substitution with limits. Step 1 is change limits. Step 2 is change the integrand into being in terms of u. So we want to change the thing inside the integral to in terms of u. And step 3, which is easy to forget, is we want to get dx in terms of du. So replace in terms of du. If we do all those 3 things, then we've done all the bit that's difficult from the substitution. There's then integration that's left needing to do, but those are the key things we have to worry about first. So the first step should be fairly simple. So these limits here are these -1 and 0 are values of x. We're going from x equals -1 to x equals 0 if we think about the graph and thinking about the areas. So to get our values of u, well, if x equals -1 and u is 2x plus 3, then u is 2 times -1, which is -2, plus 3 will give us 1. So our bottom limit becomes 1, and our top limit, if we put x in 0 in there, we do 2 times 0 plus 3, and we get 3. In this case, and in most cases, you will still get that the top limit is bigger than the bottom limit. If you do get the top limit to be lower than the bottom limit, don't worry, but keep it that way around. It will work out. I know that any other time we're integrating, we're always going to have the top limit as higher. But if your substitution does give you a top limit lower than your bottom limit, don't worry, just keep it going, keep them that way around now. Okay, so that's step 1 done. Step 2, we need to get this integrand 6x squared over 2x plus 3 in terms of u. Well, the denominator, good news, is going to be nice and easy because we've chosen this, so it's nice and easy. That's just u. The numerator, on the other hand, definitely not that nice and easy, so we're going to have to do some algebra over the side here. We know that u is equal to 2x plus 3, so 2x is equal to u subtract 3, and x is equal to u minus 3 over 2. I'm going to do as much algebra as I can over here to sort things out before I try subbing in. So x squared would be u subtract 3 all squared over 4, because I've got a squared numerator and denominator. So 6x squared is going to be, well, I could write it as 6 u subtract 3 squared over 4, but I might as well simplify that to 3 u subtract 3 squared over 2. That's as good as we're going to get there. So that's my numerator here. I am going to have a fraction within a fraction, but we can worry about that in a minute. So we've got 3. In fact, I'm just going to write 3 over 2 lots of u subtract 3 squared. But that's equivalent to what we've got over there. I'm just choosing to write the 3 over 2 out to the front. And step 3, we need to relate dx and du. So what we're going to do, we've got u in terms of x here. So what we can get straight away is du by dx, simply by differentiating with respect to x. And 2x plus 3 differentiating with respect to x is just 2. That's nice and easy. At this stage, du by dx isn't a fraction. It's what a fraction tends to in a limit. It's not a fraction itself. But when we're doing integration by substitution, for all purposes, we can treat it as though it is a fraction at this stage. So this video is just about the implementation. I'm not going to worry about the justification here, more the implementation. So if we treat this as a fraction, we can say du is equal to 2 dx, multiplying both sides by dx, and we can rearrange a step further, divide by 2, and we get dx is half du. So when we're replacing dx, we're going to replace it with half du here. So that's, in effect, we're just multiplying by a half here. Okay, we've got something to work with now. That 3/2 is making our life a little bit harder. The half we can also try and deal with as well. I would recommend, once you get constant multiples going on here, factorize out what you can. So we can factorize out this 3/2. We can also factorize out the half. So if we factorize in now 3/2 times by a half, then we can get 3/4, and we can write that right at the front of the integral, worry about that later. And then we're just left with the integral of u subtract 3 all squared over u with respect to u. This is now a sort of integral we should back ourselves doing. We've actually done everything to do with substitution now. We just need to be confident integrating at this point. So how can we deal with an integral like this? Because these do come up a lot when you're doing substitution. So looking at our numerator, let's just expand. We've got u squared subtract 6u plus 9 all over u du. I know people have different ways they like to deal with this. You can either think about this as being u squared subtract 6u plus 9 multiplied by u to the negative 1 and expand your brackets. I prefer to think about this as just splitting up the fraction. So we can think we've got u squared over u, which is just u. Then we're subtracting 6u over u. Well, 6u over u is just 6. And then we're adding 9 over u. And straight away I'm going to write this as u to the negative 9u to the negative 1, because it'll make it easier for the next step of integrating. Although you could, to be honest here, you could write as 9 over u. It would probably be similar and nice. Okay, we now need to integrate this 3/4. Again, we can just keep outside here. When we're integrating, well, u integrated just integrates to half u squared. That's nice and easy. 6 integrated just integrates to 6u. Again, nice and easy. Now, 1 over u, or u to the negative 1, integrates to ln u. So 9 loss of that is just going to integrate to 9 ln u. And whenever we integrate 1 over u, we should be putting ln of mod u. In this case, it won't matter, but it's making sure our answer is defined and it all works nicely. Our limits are still 3 and 1. And at this stage, we've done all the hard work. We just need to substitute in now and see what happens. So we're going to get 3/4. I'm going to get big brackets here, and we're just doing half times 3 squared subtract 6 times 3 plus 9 ln. And mod 3 is just 3, so I don't need to worry about that at this point. And then we're taking away what happens when we sub in 1, so half times 1 squared minus 6 times 1 plus 9 ln 1. Now, there's some things which are going to go nicely. I would show this whole step. It feels like overkill, but in terms of method marks, you want to show what's going on when you substitute in, and you might as well show it all. You still need to be careful, even if it's a 0 on the bottom limit. Really common mistake is to see a 0 and not worry about it, ignore it. But in a case like this, it would really have an effect, because the ln of 0 would be undefined. But you should be careful whether 0 will give you 0 or not, or will give you something else. So now we just need to go through and do a bunch of arithmetic. So a half times 3 squared is 9 over 2. Subtract 18. 9 ln 3, let's keep like that. Let's keep our answer exact. And then we're taking away, well, a half subtract 6. And then ln 1 is just 0, so I can ignore that now. And we're getting this. By now, we just need to go through, simplify. We go inside the brackets. If we do 9 over 2, subtract 18, and then subtract half minus 6 in the brackets, that should give us minus 8, and then we're going to have 9 ln 3 here. And now we can finally deal with the 3/4. And we're going to end up with 27 over 4 ln 3 subtract 6. Advice on these questions: once you get your final answer, go to your calculator, type in the original integral to your calculator, and check it gives you the same answer. Your calculator won't give you the exact form, which we want, but you can always check that it's giving you the right decimal form when you put it in. But most times on an exam question, you'll be asked to leave your answer in exact form, which here means leaving it in terms of learn. Worth mentioning what happens if we don't have limits. Our approach would have been the same all the way through. If our integral didn't have limits, then we wouldn't have had to worry about step 1 here. We'd have just gone through exactly the same as everything else before without this 3 and 1. Now, once you integrated, firstly, you'd have had a plus c, because whenever there's no limit, whenever you've got an indefinite integral, you need a plus c. But you wouldn't have wanted to leave your answer in terms of u. If you're doing an indefinite integral, our original question was in terms of x, so you'd want to give your final answer in terms of x. So rather than leaving like this, you'd want to go back and say, well, hang on, u is equal to 2x plus 3, so just replace all your u's with 2x plus 3, and that's you done. Next video I'm going to do in the series is going to be on nonlinear substitutions, where the replacement of dx in terms of du is going to complicate matters a little bit. Thank you very much.